Hello everyone, welcome to In 5 Minutes. We will discuss multi-stage implementation of sampling rate conversion in this particular video clip. We have discussed two types of sampling rate conversion, one in the form of decimation and one in the form of interpolation. In practical applications of sampling rate conversion, we often encounter decimation factors and interpolation factors that are much larger than unity. For example, suppose that we are given a task of altering the sampling rate by the factor of I by d equal to 130 by 63. Let's say this is the sampling rate conversion that we have to carry out. Now here you can say that you will require interpolation by 130 and decimation by 63. So although in theory this rate alteration can be achieved exactly, we can discuss the theoretical implementation of this. We can have interpolator with the factor of 130 and decimator with the factor of 63. However, in practical implementation, it will require a bank of 130 polyphase filters because we are doing interpolation by a factor of 130. So whatever is the maximum number, those many polyphase filters will require. So a bank of 130 polyphase filters will be something computationally very inefficient. So in this section, we will consider methods of performing sampling rate conversion for decimation, which is very large, or interpolation, which is also very large value. We may have both to be performed, interpolation as well as decimation as a rational factor, and both may be very large in number. This can be done in multiple stages. So what do you mean by multi-stage implementation? It simply means that if I want to, let's say, carry out interpolation by a factor of 130, then I can do it in two stages. In first stage, I can do the interpolation by a factor of, let's say, I1 equal to 13. In the second stage, I can do the interpolation by a factor of, let's say, I2 equal to 10. So when I do the interpolation of 113 two stages, once by 13 and once by 10, the overall interpolation will be by a factor of 130. That's simply because first you are upsampling by 13, so the output rate of the first block will be 13 times effect, and then you are upsampling by 10, so the final output rate will be 10 into 13 effects, so that will be 130 effects. This I can split this further. I can have first stage of interpolator with a factor of 13, the second stage with the factor of 5, and I can have third stage of interpolation which will be by a factor of 2. So this will also give me the overall interpolation by the factor of 130. As you can see, 13, 5 and 2 will multiply to 130 once again. So similarly, I can apply this to interpolation also. So let us assume that I can be factored into a product of positive integers. If that can be done, I can write capital I is equal to pi I small I, where I will vary from 1 to some number L. L will become the number of stages. In this case, interpolation by a factor of I can be accomplished by cascading L number of stages of interpolation and filtering, because after every interpolation we will require filtering operation also.